Okay, so what we're going to look at in this really short video is the area bounded by equations. And it's very similar to what we did, it's just the wording seems weird. So let's say that you're given these equations. Y equals, let's use 5x squared plus 2. And then you're also given the equation x equals 0, x equals 2, and y equals 0. So a lot of times students just struggle with this just because what does it mean? So basically they want you to look at this region that all four of these equations make together. So you have to remember just some of your algebra stuff. So it's not that hard. It's actually pretty easy. You just have to get a new an integral. So let's start with x equals 0. Remember this is a vertical line. So think of that. X equals 2 is another vertical line. Those x equals, those are actually going to be our boundaries, our A and our B. Okay? Those are going to be our A and our B. This y equals 0 is a horizontal line. So right now, if I look at this, I'm going to change to a different color. I have x equals 0, which is here. Then I have 1, 2, then I have x equals 2, and then I have y equals 0, which is a horizontal line. So right now I'm talking about in this area. Then this top part, which is actually the function we're looking at, it's more of a function than just a horizontal and vertical line, will tell us what the top of this curve looks like. So do you have to put every point in? Not necessarily. You only need to know at 0 and 2. So what you're going to do is you're going to plug 0. You're going to plug this 0 in for x. So if I put 0 there, that gives me 2. So I'm at 2. Here's my point. And then I'm going to plug the 2 in for x. So 2 squared is 4. 4 times 5 is 20, plus 2 is 22. So that means this other one is way up here at 22. So it's curving because it's a parabola, so it's going to look like this. So that's the area I want in here. So how are you going to find that area? So first we graph using these. Remember, these are horizontal, these are vertical lines. This is horizontal, so horizontal and vertical, and this is your curve. So then you think, what would my integration actually look like? I'm going from my A, which is here, and my B, I'm going from 0 to 2 of 5x squared plus 2 dx. So you can write that integral. And then you can evaluate it. So that would give me 5x cubed over 3 plus 2x, and I'm evaluating from 2 to 0. I love it when we have 0 because it usually makes it easier when we have 0. So if I put that in 2, that would give me 5 times 2 cubed is 8 over 3 plus 2 times 2 is 4. So that's my f of b from what we talked about the other day. And then we have to subtract f of a. Well, if I put 0 in, that's 0 and 0, so I'm subtracting 0. So really, who cares what that is? So then we just got to do some math here. 5 times 8 is 40 over 3 plus 4. Again, here I am without my calculator. 4 is 12 thirds, so that would actually give me 52 thirds for my area. Could you type that into Desmos and check it? Yes. Definite integrals, because they have numeric answers, some of your graphing calculators will even evaluate them, but I always use Desmos to check. So that's it. So when you're going to have a couple of these today, just remember x equals are vertical lines. These x equals, those are going to be your boundaries, your A and your B, your A and your B. This y equals 0 just means I'm above the x-axis. If you take Calc 2, you will do some other things like this, where you'll look at this and then you'll rotate the whole shape to get something new. But so that's why it's important to realize that this x equals 0 and x equals 2, those vertical lines are just your boundaries. That's it. Hopefully this video is a lot shorter than the last couple.